Leptons are subatomic particles that have a charge of either -1 or 0. There are 6 different leptons: the electron, the muon, and the tau, all of which have a charge of -1, while the negative counterparts, the electron neutrino, the muon neutrino, and the tau neutrino, have a charge of 0. The muon and tau leptons may seem to sound different to the electron, but in reality, they are simply unstable versions of the electron. The neutrinos are interesting because they are particles that have almost no mass and have no charge. Bosons have an integer spin number and can occupy the same quantum space. Bosons are also known as forces, like light and gravity. There are 4 confirmed types of bosons: the well-known photon, the gluon, and the W and Z bosons. There is believed to be a boson for gravity called a graviton, but its existence hasn't been proven yet, as gravity is a very weak force, and therefore finding a graviton would be extremely difficult.
Mass-energy equivalence is derived from Einstein's famed theory of relativity, E is mc squared. This equation states that energy of a particle is determined by its mass multiplied by speed of light, c, in a vacuum. Therefore, mass and energy are equivalent because if c equals to 1, then E equals to m. This is one of the first theories to clearly state the relationship between mass and energy, giving several implications and leading to several groundbreaking discoveries in Einstein's time. For example, absorbing energy, such as iron absorbing heat energy, or in other words, iron being heated up, will subsequently increase its mass with sufficient increase in temperature. Additionally, this led to the subsequent discovery of nuclear weapons in the Manhattan Project with splitting of the atom, and as we know, did not really end very well in World War II. Due to the extremely high speed of algebra and its particles, despite their low mass, they contain enormous amounts of energy which could be harnessed for many applications, such as nuclear weapons and nuclear energy.
Radioactivity is when a nucleus releases energy through radiation in order to create a new nucleus. This is known as radioactive decay, and it occurs when the nucleus is not able to hold itself together, and it breaks down in order to stabilize itself. There are 3 main types of radioactive decay: alpha, beta, and gamma decay. These types release different things in order to satisfy certain requirements. Alpha decay is when alpha particles are released from a nucleus in order to become more stable. These alpha particles sound complicated, but in reality, alpha particles are simply 2 protons and 2 neutrons, which is identical to the nucleus of a helium atom. In fact, it is written the same way in chemical equations. Beta decay releases an electron, or a positron, which is the antimatter counterpart to the electron. A gamma decay is when only energy is released, in the highest energy form of light, also known as a gamma ray. Gamma rays are past the visible spectrum and have 10,000 times more energy than regular light. Gamma rays are so strong that it can convert into matter, and it can instantly kill a man. Although there are 3 different types of radioactive decays, most decays occur in a chain, going through several different types of decay until the nucleus is finally balanced and satisfied.
Many technological innovations we have today are as a direct result of our increased modern-day understanding of the nature of the atom and elementary particles. For example, it is only with Schrödinger's quantum model of the atom and the discovery of wave-particle duality are the compact electronics we use every day possible, such as transistors, CDs, and hardware. It is only with the understanding of wave-particle duality that electrons can behave as waves where these electronic innovations possible, all with the understanding of the movement of electrons. For example, prior to this and the invention of transistors, computers and televisions were limited to the use of large and efficient vacuum tubes. Without the discovery of wave-particle duality, our expensive, super thin, super light, super expensive MacBooks will be a thing of science fiction. With the recent discovery of the Higgs boson particle at the CERN Hadron Super Collider in Geneva, scientists are now able to apply this to the theories of the universe. For example, suggesting the Higgs boson may be responsible for the expansion of the universe in the Big Bang. For better or for worse, the discovery of mass-energy equivalence has severely impacted the political climate of the world for the past 40 or 50 years, with the invention of the atomic bomb.
Created using Powtoon.